Hello and welcome to another episode of Envisioneering Exchange, the podcast where industry leaders discuss the most important topics in building and urban efficiency. I'm your host, John Sheff, Danfoss's Director of Public and Industry Affairs. You can subscribe to our show on Apple Podcasts, Spotify, SoundCloud, or wherever it is you get your podcasts. Today's topic is water and wastewater infrastructure, and I am thrilled to be joined by my guest, John Masters. John is currently the Industry Affairs Advisor for Danfoss Drives, but he was formerly a VP of Sales in our Drives Water segment. He's been a leading voice in the industry for years, and I am excited to talk to him today about water infrastructure as we enter a new administration with big infrastructure ambitions. Now, John, when we typically think about infrastructure, we think about roads, bridges, tunnels, but water and wastewater infrastructure in this country is badly in need of investment and critical to our economy. Can you introduce yourself and then explain a little bit what we mean by water infrastructure and why it's so important?
Sure, John, thanks. As you said, I've been VP of Sales for the Drives Water segment for the last 15 years and recently moved into the Industry Affairs Advisor position, and excited to be part of that and hoping to help drive some of the important water issues further. Yeah, when we talk about water infrastructure, it's a broad range that we're talking about. We're really talking about everything from the water source to the actual discharge of wastewater into a stream or a lake or wherever it might be discharged. And we look at the overall system as everything from the piping systems, or I guess originally from the pumping systems, whether it be from a well or from a groundwater source, lake, river, stream, whatever, to the end user, possibly a treatment facility in between that, and then the wastewater, again, going from the end user to the wastewater treatment facility and eventually discharged into a stream. The big issue with that is that many of these systems are decades old. I worked for an engineering firm back in the 80s, and some of the systems that we designed back then are still in operation today with very little upgrades. So this has been a major concern for water shortages, right? I mean, that's going to be one of the issues. And I think the urban expansions has put more stress on the systems. And so it's become a very important issue.
Oh, yeah. And I think we're seeing it right now play out in live with what's happening down in Texas and all the water issues they're having there.
Exactly.
And just the stresses on these systems as weather gets more extreme, as urban centers expand, and we really don't take care of these really important pieces of infrastructure that are really taken for granted. I mean, I think we've seen it a little bit, but explain what are the risks if we fail to maintain and upgrade these systems?
Well, like you said, I mean, we're seeing some of the things in Texas susceptible to failures in the system, leaks, water main breaks, things like that. That weather really emphasizes things that we deal with in the north. I'm out of Wisconsin, so we deal with that on a regular basis. But as the ground freezes and shifts, the pipes can break, and the older the pipes, the easier they are to break. So what we look at then is that going to cause water shortages, contamination of water supplies. Almost every week, there's a community near us that's got a boil water order in place simply because they've had a main break and are concerned about that. So it's a big issue from that standpoint. Also, non-revenue water is a big issue. When we talk about these old systems, there's leaks in the systems. They might be small leaks that are undetectable, but there's some studies that were done that like a quarter-inch hole at 100 PSI is something like 1 million gallons a year. And you can imagine how many quarter-inch holes might be in an older system. So it's a big issue there that the water's being pumped, but it never gets to the end user. So it's an added cost. And then, of course, the other concern on the wastewater side is that if we don't have these systems upgraded that have failures at the treatment plants, and we end up putting raw wastewater into the receiving stream. And then, of course, inefficient. The systems, as I said earlier, we did a lot of the designs many years ago, and were designed inefficiently for both pumping and treating.
And like I said, I think that we just take these systems for granted, but they can really cause a lot of issues if they fail. So in the past, how were these systems traditionally built, and how can they be upgraded to meet our modern needs today?
Yeah, it's interesting because, as I said, I worked with a consulting engineering firm back in the 80s, and we had guidelines to go by, right? In the Midwest, it's called 10 state standards. So there was criteria that was mandated as to how we actually sized and our pumps, our piping systems, all of that stuff to meet these 10 state standards. And a lot of that design criteria was based on projecting forward 20 years. So we build a wastewater treatment plant today, look 20 years ahead and say, well, what's it going to look like then? And size the pumps according to meet the demand with the increased population, maybe industry coming into a community. So the ultimate result of that is that we have oversized pumps, motors, blowers for aeration equipment. So what this causes then is the cycling of these large pumps, very inefficient operations. Aeration blowers are running at full speed with no control. This can be improved with smaller multiple pumps if we try to look at ways of solving the problem, and then control the pumping to match the demand, cascading the pumps as the flow increases, turning them off as the flow decreases. And the same thing with controlling blowers. We can actually, by bringing inputs from dissolved oxygen analyzers or ammonia analyzers, we can match the needs of the aeration system with the blower speed.
And yeah, I think this trend that we saw in the past of oversizing these units is not just in water and wastewater. We see it in HVAC all the time, where systems are really oversized for the way that we use them 98% of the time. And so there's a lot to be done in trying to match demand to actual use. So I think that makes sense in a retrofit capacity. But in terms of these new facilities that are being built, what are the technologies that are going to the state-of-the-art waste and water systems?
Yeah, well, we can look at entire systems. The water piping systems, the materials and so forth that are used for those are much better than they were in the past. So, some of the new developments in the piping system certainly help with the water distribution side of things. And we get to the wastewater collection systems. Right now, we've got advanced pipe lining systems that are available that they can line the old pipes to prevent leakage of raw sewage into the ground, things of that nature. But, many of the older technologies have simply been modified just through trial and error. Improvements in the aeration diffusers is one thing. Membrane bioreactors is another new advanced technology that's being used in the wastewater side of things, which provides much tighter control. But I think for the most part, operational modifications and strategies used to actually control the process, especially in the wastewater side, are the important things. We now have much more advanced monitoring devices. The flow meters are better, dissolved oxygen sensors, ammonia and nitrogen sensors. Those things are much better than they were in the past. And we can rely on those signals to maybe tie it into like a variable speed drive to match the pump speed to the load coming into a facility or the demand for water within a community. Match the blower speeds based on the treatment process, and also allows you to identify failures, that if the pumps aren't pumping what they're supposed to, the variable speed drives now have the technology to actually identify that and provide warnings. But yeah, I think just, better monitoring technologies and operational strategies are one of the huge things. And then, even if you go out further in the system, there's been a huge drive towards green infrastructure, basically reduce the demands in the system. So in the larger cities, I know California has implemented this in a lot of cities, especially San Francisco, but you can't build a new building without green infrastructure. And when I say green infrastructure, I'm talking about maybe rooftop greenhouses or gardens or these tree boxes that you'll see on the street, so that the gray water that's used, what's fairly clean water, is simply being used to irrigate plants and so forth, and not end up in the sewer system where it has to be treated.
And yeah, I think that's a huge distinction between how we used to do things and how we do things now. I worked on some projects where trying to upgrade old wastewater systems and old sewer systems, and just the philosophy back when these things were built in the 50s, 60s, and whenever these communities were built, was to move the most amount of water out into wherever it was, whether it was a stream or the bay or the harbor or wherever it was. And it's just not the philosophy now, is try to diffuse that into the ground and try to do something with it, like you say, with the gray water. So just a total change, I think, in how we think about these things and what the impacts of moving this water into our waterways is.
I agree. I think it's people have become more knowledgeable of where the water is coming from. Many people in the past were simply you just expected that when you open your water tap at home, that water was going to come out and it was going to be clean and drinkable, right? And we're finding that in some cases there's concerns with that. So the more that we can do to protect those systems and treat the water, the better off we are.
Yeah, and and to touch on one more thing you said, just variable frequency drives have been around for a while, and yeah, the technology has gotten better. But like you mentioned, it's really the amount of data and the sensors that we can get into places to control and to feed those drives and match that demand to need and to flow is really what's changing things, I think. And I think it's a really good point. And speaking of that data, how does energy efficiency come into this equation?
Well, energy efficiency is certainly important. I mean, the real task, if you talk to a public works director or plant operator, whatever, their task is really to provide clean water, whether it be the clean water that goes to the customer or clean water that's discharged into the streams. So with that, they have to balance the pumping, the treatment of the wastewater and so forth to really ensure that it is clean water, right? So, and there's a tremendous amount of energy that's used from, right from the well to the discharge. I mean, we're pumping water out of the ground, we're pumping it long distances to various houses. It's then discharged into a collection system, which has pump stations that pump it to the treatment plant, and then all the processes we talked about previously about treating the wastewater. It's very energy intensive. So anything that can be done to improve energy efficiency is important. And I talked about variable speed drives, and that's certainly a technology that has been adopted very well over the last, I'd say, 20 years. I mean, 20 years ago when we first really started pushing drives, the idea of using drives in wastewater treatment plants and water plants, there was a lot of pushback simply because they were looking at, well, geez, this is a little bit unknown technology. If I try to slow down the speed of my pumps, am I going to affect the quality of the water that we're pumping? Those types of things. So now the goal is that we're going to provide clean water for drinking. We're going to actually have clean water discharged into the streams, but we're trying to do it in a more energy neutral facility. And when I say energy neutral, I mean, energy neutrality is one of the buzzwords that we're seeing a lot. And the idea is to really take those processes, monitor them, provide feedback to devices such as drives and so forth to operate the systems more efficiently. We're seeing now that for a period of time, anaerobic digesters, I guess, had a bad name, and they're very energy intensive and hard to control. Well, now we're able to control those better. And the anaerobic digesters produce gas and methane gas, and that methane gas can be used to operate a CHP process for cogeneration and actually supply power back into the facility to run the facility. And Danfoss has worked with several communities around the world where we've actually, through controlling pumps with variable speed drives, using the CHP processes, better gas production and so forth, we've achieved like 180% energy generation. So not only are they supplying all of the energy to operate their facility, they're generating 80% more energy that can be used in other parts of the systems. And one community in Denmark, Aarhus, they're using from the wastewater treatment facility, generating 180% or more energy, and that 80% is being used now for the pumping side of things for the water. So it's really an important process. And if you look at what was the biggest bill that a community has every year, it's probably the energy bill at the wastewater treatment plant. So anything that we can do to reduce that is huge. And then the other thing that we don't talk a lot about with that is, the water loss. And so when we're looking at the clean water that's being given to the consumer, and I mentioned before about leakage in the pipes and so forth, in the past, we simply put up water towers and we pump at 100 psi or whatever up to the top of the water tower and then allow that to control the pressures in the system. And now what we're seeing is groundwater reservoirs where you don't need as much pumping to pressure to pump into the reservoir, and then control the pressure in the system to meet the needs of the community. So you look, what's the furthest distance consumer that we have out there, and we just want to make sure we supply 40 pounds of pressure, let's say, to him. And what that does in not only operating more efficiently, but I mentioned earlier the fact the leaks in a pumping system where a quarter-inch hole has a high volume of losses in it, you now reduce the pressure from maybe 80 psi to 40 psi, and that amount of water loss is decreased also. So a lot of things tie together. We talk about the synergies between water and energy, and especially in a water and wastewater system. That really holds true.
Yeah, I think that's incredibly important, is looking at this system holistically and really looking at it. How can we conserve energy and also use what's wasted? I think that example of the anaerobic digester and what they're doing in Denmark is really incredible. And I hope that those technologies and those operations come to this country more and more.
Yeah, we are actually seeing it in a lot of cities in the U.S. now. I mean, we've held seminars and talked about the successes in Denmark and some other parts of the world. And there's a lot of the larger cities in the U.S. that are looking to adopt those strategies and actually now producing energy that reduces their total energy bills.
That's awesome. It's cool to be a part of that as a company. We talked about the system overall, but Danfoss does produce the power electronics and the drives in these systems. So, and this is what you did for many, many years. Tell us a little bit about the role of the variable frequency drive and the power electronics in these systems.
Yeah, so I got hired at Danfoss primarily because of my background in water and wastewater. And this is back in late 1999, 2000. And at that time, as I said earlier, the adaptation of VFDs in water systems was not that great. But Danfoss saw, or I guess had the vision to see that there was a need to actually provide software within the drive that would assist in controlling the systems in a water system. So at that time, we came out what we refer to and still today refer to as the Aqua Drive, where we've incorporated various types of software in there to improve the performance of the pumping systems and aeration systems. The drives themselves operate at better than 98% efficiency, so the use of them in general, compared to some of the other drives that were around years back, is much, much better. The pump control features that are in there are designed to assist. I mentioned before about cascade control, where you can cascade multiple smaller pumps to meet the demand. So the drives have cascade control built into them. We have empty pipe detection. So if you do have a main break, it can forewarn you that something's happened in your system, and you can shut the pump off so you're not pumping a lot of water into the streets and stuff. I'm sure we've all experienced that, where we're driving down a street and we see water bubbling out of the ground somewhere. And in the past, that would just continue to run until somebody called the fire department or somebody to tell them that, hey, there might be a water leak there. Well, now the drives can actually detect when you have these large leaks and shut the system off. There's like end of curve detection. So kind of the same scenario where you can identify when the pump is just continuing to pump without any head against it, right? We have pre-lube in there, so now the drives can tell the pumps that they need to start a pre-lube system because we're going to call for them to start in a short period of time. Flow compensation is for pressure control. That's something that we use to in the water system. So as I mentioned before, you have somebody at the end of the line and you want to ensure that they have pressure. And what happens is that as you increase the flow rate, you have more friction in the pipe and the pressure actually decreases. So what the flow compensation does is actually increase the pressure set points to compensate for the larger flows. So it keeps a more consistent delivery of water to the customer. And the wastewater side, I mean, there's things, the deragging is something that we have on the drives that actually detects when a pump is clogged and can actually reverse the pump and declog it, get rid of any material that's at the impeller, and go back into operation. Where in the past, the efficiency of the pump would continue to drop off until it was virtually plugged, and then somebody would have to go out in the field, pull the pump out and remove the rags and so forth. So some huge benefits for that. One of the newest things that we introduced about a year and a half ago is what we call condition-based monitoring. So this is a predictive capability of the drive to identify when there's issues with the motors, with vibration, things of that nature. So you can kind of have a pre-warning that you need to do preventive maintenance on it. So a lot of flexibility and information that can be used to operate more efficiently.
Yeah, it's amazing how powerful these things are. Even the people who operate them, at least in my experience, don't really understand quite how much data and how much control is really coming out of these things. They're really a powerful piece of electronics.
A lot of the larger communities, I mean, they have PLCs and distributive control systems that they can program some of this stuff into, but not all of it. And the smaller communities just don't have that capability. So by providing that in the drive, say at a remote pump station, it really opens it up to all of the consumers.
Yeah, it's incredible. Switching gears a little bit from your former role to looking at what you're doing now, and really as an industry advisor, looking at Danfoss's place in the industry and also how the industry is positioned in the larger market. What are the policies we should be advocating for in any proposed infrastructure legislation that could be coming down the pipe any day now?
Yeah, I think that's an interesting topic, because one of the few things in politics that is bipartisan is the funding for infrastructure, right? It seems like both parties have been very good about that funding, and it's going to continue with the Biden administration. But
or at least they're talking about the funding for infrastructure.
Exactly. So let's hope that continues. But when we talk about infrastructure, one of the issues there is that you mentioned before, we talk about roads and bridges and things like that, and they set aside some money supposedly that goes to water infrastructure. But unfortunately, a lot of times the upgrading a sewer system or a water system that's all underground is not very visible to the public. So, a lot of local politicians many times choose to do projects that are more visible to show that they're, helping the community and stuff. One of the, you'll see water towers popping up. And I mentioned before, how inefficient operating a water tower might be in the system. But, if you can put the name of the town on there and everybody sees it, it looks like they've invested in the community and spent a great deal of money. So really, I think educating the local communities and stuff on some of the, I guess, better means of energy efficiency, really make them understand that there are better ways of doing things that maybe aren't quite as political as that. So, but I mean, the whole goal is to ensuring that we have adequate water supply, right? I mean, and so somehow directing the funds just so that we have system integrity. I look at through the years, read different things. And one of the amazing things to me, and I know they're working on this now, is that the water system for New York City is fed by an aqueduct that comes out of the Adirondacks. And the piping for that is about 20 foot in diameter, but it's made out of wood. Mm-hmm. It was built back in the early 1900s.
Incredible.
Yeah, and I know it's of concern of New York Public Works that they have to upgrade that. And like I said, I know they're working on that. But that's just one example of some of these old systems that really need to be upgraded. So I think just driving the thought process into what can we do to improve the systems for both ensuring the water quality and energy efficiency, and not worry so much about what it looks like, I guess, is what it boils down to.
And I think that makes sense. But I think you brought up a good point there, is that we're talking about federal spending, but these systems are typically operated at the local level, and they're the ones that are actually going to be doing the project. So how does that process work, and does it work?
Yeah, I think, yes, it is federal funding, but the federal funding goes to the states. And most of the states have what's referred to as a state revolving fund. And what they do is they utilize that federal money in this fund to finance projects, local projects with cities or towns or different municipalities based on the needs. So each community hires an engineering firm to assess the needs for growth, for improving their wastewater or water systems, and present a document to the state that really outlines what their needs are. In the state, in Wisconsin, the Department of Natural Resources, reviews that and sets a criteria for what is the most important, and then provides this funding through this state revolving fund that is actually just a low interest loan to the community so that they can proceed with expansion of their plants or improvements of the sewer systems or water systems. And then as they pay back that money, that revolving fund continues to be refreshed and is available to other communities. So the more federal money that comes into that, the faster we can take care of some of the older infrastructure. And I mean, you hear tremendous numbers in order to really fix our infrastructure, our water infrastructure. It's billions of dollars that are required, right? I mean, it's a huge number and it's going to take time, but it's certainly, I know it's on the minds of everyone. And especially, like you said, when you see these disasters that occur and people without water and electricity, that becomes more in the forefront.
Yeah, it's definitely important. And I think this process that you outlined is really important to keep in mind as we talk about infrastructure legislation, infrastructure funding at the federal level, and realizing that it really is that step down process from the state and then to the local communities where the projects actually get done, the infrastructure is upgraded, and the jobs are created. So really important. So as we kind of wrap up here, we take the last question to talk about the future. We've talked a lot about on the show microgrids. We kind of talked about sector coupling before, and we talked about using anaerobic digesters and the waste heat and the waste energy produced. But in terms of microgrids, we've seen, the energy sector, for instance, gravitate towards decentralized systems and to kind of move towards a more sustainable and resilient future. Do you think we'll see that in wastewater and water, where we'll see smaller, more decentralized systems in the future, or are we going to maintain the status quo with larger centralized systems, even as we see communities expand?
Yeah, I think that's going to be something that's kind of on a case-by-case basis. But the trend that I generally see, quite honestly, John, is that we're seeing expansion of larger facilities and moving away from maybe decentralized facilities in a lot of cases. And one of the reasons for that, and it's actually tied to the energy efficiencies, right? That in order for an anaerobic digester to be effective, you need certain amounts of waste of various kinds and a certain volume to really make it worthwhile. So as they start looking at energy production, energy neutrality, the larger facilities are looking to get more waste brought into them, and so that they can generate more electricity. So I think the trend, it varies. If you have, with urban sprawl, you have some of the subdivisions that are way out that it maybe costs more to pump it into a central system, where then you need to have a wastewater facility nearby to accommodate that. So I think it just kind of varies. But from what I see, the trend is more towards centralization because of the benefits for larger facilities for energy production and energy neutrality. And what we're finding is that we're seeing more and more communities look at privatization of their water and wastewater systems. And with that, I think that'll drive even more of the centralization.
Yeah, I think that's really interesting to keep an eye on, is this privatization as communities kind of take control. And we've seen it in the utility sector too, as communities look at privatizing their local utilities. So interesting and something to keep an eye on for the future. And John, I really want to thank you for joining us today. That's it for this episode of the Envisioneering Exchange. Again, I'd like to thank my guest, John Masters of Danfoss, for joining us. And don't forget to subscribe to the Envisioneering Exchange on Apple Podcasts, Spotify, SoundCloud, or wherever it is you listen to your podcast. And lastly, if you enjoyed this episode, don't forget to rate, review, and share with your network. Again, my name is John Sheff. I'm the Director of Public and Industry Affairs at Danfoss. Thanks for listening, and talk to you next time.
This podcast is for information purposes only. The views, information, or opinions expressed during the Envisioneering Exchange podcast series are solely those of the individuals involved and not necessarily represent those of Danfoss LLC and its employees. Danfoss LLC is not responsible and does not verify for accuracy any of the information contained in the podcast series available for listening on this site. This podcast series does not constitute professional advice or services. This podcast, including Danfoss LLC and the producers, disclaim responsibility from any possible adverse effects of information contained herein. Opinions of guests are their own, and Danfoss LLC in this podcast does not endorse or accept responsibility of statements made by guests. This podcast does not make any representations or warranties about the guest qualifications or credibility. Individuals on this podcast may have a direct or indirect financial interest in products or services referred to herein. This podcast is available for private, non-commercial use only. You may not edit, modify, or redistribute this podcast. The developers of the Envisioneering Exchange podcast site assume no liability for any activities in connection with this podcast or for use of this podcast in connection with any other website, computer, or playing device.